So we are going to talk about ionic crystals. An ionic bond is formed between metal and non-metal. Usually a metal which has excess electrons in its valency tries to lose its electron, and a non-metal which has one vacancy in its valency, it tries to get one electron. So these two form a bond together by exchanging, in other words, by giving away one electron from non-metal to a non-metal. That's how they form a bond. So this is how they make strong crystals, and these are called ionic crystals. An example of an ionic crystal is NaCl, in which the sodium, which is Na, loses its electron and becoming Na plus, and it gives away its electron to chlorine, and that's making the chlorine as Cl minus. The next type of crystals are covalent crystals. Covalent bond is formed between two atoms with the partially filled outer shells. So whenever there are any electron shared between two adjacent atoms, then we call it covalent bonds, and it could be between adjacent or between the whole entire elements in the whole entire atoms in the compound. So that is just sharing between atoms is called covalent crystals, and electrons are shared between the atoms, causing an attractive force, thus making it a very strong crystal. Several crystals are considered to be purely covalent, such as diamond, silicon, germanium, and some other crystals are partially covalent. So example is gallium arsenide. So when we say partially, it could be one of the atoms will be valence electrons will be shared by both of them. So in that case, we call them partially covalent. Otherwise, one from this atom, one from the other atom, they both will be sharing both atoms together. But in some, just one of the valency electrons from one of the atoms will be shared by both of them. That is called partial covalent. The importance of bonding. Carbon solids are formed by several different bonding structures. Each structure may exhibit vastly different physical and chemical properties, and based on what type of structure that it is forming, it could be the hardest material on the earth. It could be a very fragile by touching with the nail too. So the carbon solids which are formed by this covalent bond will be a little bit different in their performances. So one of the examples is diamond. We all know that diamond is extremely hard and extremely high melting point and all carbon-carbon bonds. And the diamond is the hardest material existing on the earth. And the other example which has the covalent bond is graphite. And this is a very soft, lustrous, easily flaked, so and also all carbon-carbon bonds. So we can see that these two materials both have carbon-carbon bonds, and both are uh, the covalent bonding. Still, they both have two vastly different physical and chemical properties. Graphite has a sheet-like structure, which you can see from here. It has a sheet-like structure, and you can just separate them just like you're taking the papers. You're just flipping the pages. So that's how you could just take the sheets. Just you can take the layers of graphite out with your just regular nails. And this is the diamond structure, and it has all the very strong bonds, and we all know that diamond is the strongest bonding. So these two are completely different structures, different properties, even though both are of covalent bonding. The new carbon structure in 1985, a completely new carbon structure was discovered by the Rice University in Texas, and that is called the buckyball. And in buckyball, carbon molecule 60 carbon atoms form a cage-like structure resembling a soccer ball. So it just looks like a soccer ball with the empty patches. Like, when you have just take the patches off and just imagine that all those blocks are empty. So that is how the buckyball looks like. And this new form of carbon is currently being studied for possible applications in wide variety of areas, including medicine. So they are still, looking at the advantages and applications of this buckyball, but this is a new carbon structure. And then other type of solids are metal bonding in solids. And the metal bonds are formed between the metal atoms. As the name indicates, the bonds are formed between metal atoms, and in a metallic solid, electrons in the outer shells of atoms are shared loosely among all the atoms of the solid. So contrast this with the covalent bond, in which electrons are shared only between adjacent atoms. So in the metallic, the outer shell atoms are shared among all the atoms in the solid. But in the other case, which is covalent, you can see that the atoms are shared by adjacent atoms only. So the loose bonding electrons form a sea of electrons that can move easily about a solid. Since they are shared between the whole entire atoms in the solid, they can move freely within the solid. So that's what we call it as electron sea. And the arrangement of these electrons are responsible for the observed properties of metallic solids. We all are aware of the properties that metals are very good conductors, and these electrons C makes this possible, whether it's a good electrical conductor or the thermal conductor, because of this electron C, it makes it possible to conduct the electricity and thermal energy to pass through it. And opacity to light, lustrous appearance, all these things, which is reflection properties. So all these are the properties of the solids, metallic solids. And the other type of crystals is molecular crystals. And to understand molecular crystals, we need to understand the mechanism behind the van der Waals force. And I'm sure you would have heard of this force. If you are not aware of it, this force, we probably would have seen many times in the real life, that is the lizards and geckos crawling on the walls. So the tiny legs on the geckos or the lizards, the small pokey kind of things, they kind of stick to the wall and they make it crawl on the wall. So the force between those small pokey things of the geckos or the lizards and the wall, the whatever the force they have, that is called the van der Waals force, which is responsible for bonding in many molecular crystals. These forces are very small. That's why whenever you touch them, they just fall down, because the force between the wall and the gecko, um, those pokey things are very tiny. So that is the reason they just fall back very fast, but they're good enough to do whatever the required things they do. So these forces are very small in comparison with the forces involved in covalent or ionic bonding. Even though the van der Waals bond is considered weak, it is responsible for the coming together of the molecules in a molecular solid. So the physical basis for this force is basically a weak electrical interaction based on the polarity of a molecule. So just based on its polarity of the molecule, there will be a small tiny bonding, and that is what makes it possible. When we say polarity means the arrangement of positive and negative charges in the molecule. So we all know that any material is made up of positive and negative charges, and if you separate them as positive and negative completely, they are usually arranged in pairs of positive and negative. But if you separate them as positive and negative, then we call them, it is polarized, or the polarity, it means it is separated completely from negative. Positive is completely separated from negative. It's that way. So you can see this one right here. The water molecule has hydrogen and oxygen. We all know that. So we know that hydrogen is a positive ion and oxygen is a negative ion. So if you can imagine them as a positive all separated from negative. So if this is how the mm, water molecule looks like, then if you bring this is the picture of water, and you can see right here, this is how the van der Waals force does. So you can see that this is one is a water molecule, right? So it has a positive and negative. If you bring the other water molecule, which is again separated by positive, negative, we all know that positive, negative attracts. So other molecule comes and attracts with this positive and negative side, and they keep on making chains of it. And you can see in this picture also, you can see positive, negative, and the other side it will make. So they make small tiny molecules which are attracted by the tiny force, but when we touch them or when we try to use a little bit of force on them, they'll break. So that's how this molecular crystals form. When a polar molecule is located near other polar molecule, the van der Waals forces causes the molecule to be attracted with each other, and that's how they form this kind of molecules or crystals. Polar attraction, and polar molecules can interact with the other non-polar molecules. Let's say that if we have a polar molecule, and if you bring that one too close to the non-polar molecule, then because this has a negative, all the positives will come to one side and all the negatives will go on the other side, and it will make the non-polar material also as a polar material, and thus there will be an attraction, and it will also become a molecular crystal. So the charge in the object can become separated as shown in the picture. When the polar molecules get near to the object with a neutral charge, the charge in the object can become separated. Since water is a polar liquid, it makes sense that ice is a good example of the molecular solid. We all know that water is a liquid and ice is a solid. So this liquid, by joining together, makes a crystal that is the ice. So the molecular crystal ice forms very open crystal structure. This property is very important since it means that the density of the ice is less than that of the liquid water from which it was formed. We all know that ice is formed by water, but when you put the ice in water, it usually floats. Something is floating, it means its density is less than that of that material it is immersed in. So, it is the only liquid is less dense in solid than its a liquid form. The water is the only liquid or the only material whose density is less when it is in the solid form. Usually any other material, once it solidifies, it just gets heavier to that liquid form, or in other words, heavier means density, in terms of density. What does that mean? It means ice floats. Once the density is small, the ice floats. And more interesting facts about water. Water is the only substance on the earth which occurs in three, and that is liquid, solid, and gas. Water has the highest surface tension of all the liquids. Because water can form a skin, precipitation is possible. Water is incompressible. You cannot squeeze water into a solid ice cube, but you can solidify it by freezing, but by not squeezing. Water is a universal solvent. We all know that most of the materials can be